Hello, and welcome to something different. I make no secret of the fact that I am just a consummate nerd. And what I do when I go to the library is I usually take along one of these most often needed radio diagram books by M.N. Beatman and Supreme Publications. And I just flip through them while I'm contemplating life and see if I come across anything that piques my interest. And I often find many things that do. And I got to thinking that maybe some of this might be of interest to somebody else besides myself. And I figured, what the heck, I'll give it a shot. And if you guys think this is worthwhile, I can continue to do this. Now, while I was in here, I found this Emerson 505 schematic. And to be perfectly honest, I was so intrigued by the way they've laid this thing out, that I went to Fleabay and found 3 of them for sale. One of them was priced ludicrous, and the other 2 were priced very reasonable. So I bought both of the other 2, mainly because they both have one knob missing. One of them, the back is missing, the other one, a tube is missing, and I figured, what the heck, between the 2 of them I can probably piece together one functional, decent looking set. But before it gets here, I figured I would share with you what I found in the schematic. Now, this is one of these 3-way power sets. Very common for 1940s. They will run on battery or on line current of AC or DC. And it was considered the portable radio of the day. But what I found so intriguing with this set was how they powered the heaters. Over here. Oops, went off the screen. You're going to have to excuse me. I don't have a tablet. All I have is a mouse. Usually there's a curtain burner cord, or there's several large resistors in these sets. Some way to drop the power for these 1-volt tubes. The one T4, the one R5, the one 1S5, the 3Q4. And this set was very different. This set doesn't have resistors. It doesn't have a curtain burner cord or anything. Now, first thing I want to bring your attention to is we have a 117N7, which serves as our rectifier. Now, the 117, that's the heater voltage for that tube, runs directly off of line current. And over here, we have the other half, which is an audio amplifier. So when this is running on line voltage, this tube warms up and becomes your audio output tube and your source of DC. What's really different about this, well, let's follow that path first of all. We have the 117 N7 diode, comes up through our filter caps and a choke. And again, excuse me, I'm doing this with a mouse. The voltage comes over here, runs up, and interestingly only goes through half of the primary of the audio output transformer, turns around, comes back down to our anode. That's kind of cool. But when it's running on battery, we have what this female receptacle right here that they can point out, and you'll notice it's marked X and Y. And over here on our plug, it says polarized plug, and it's marked X and Y also. What happens when you put the plug in here is it makes contact between these 2 points, and it goes through the line cord, through the Y connection, through the power switch to ground. This is also a power switch here. When you turn on the power switch, both sections close. That runs our heaters right down here. So now we have a circuit with the plug in here. The prong of the plug closes the circuit between the minus of the A battery, the minus of the B battery, and also connects them through the line cord to ground. So now we have filament current and we have B plus current, and the B plus current is going to come out, run along this same wire. It's going to go, whoops, all the way up, and this time it's going to go all the way through the primary to the 3Q4. So we have our audio output, our B plus being supplied by the battery over here, and our audio being supplied by the 3Q4. But it really gets interesting when you plug this thing into the line. When you plug this into the line, this connection is no longer made. This connection is open. So when you turn on the power switch over here and over here, these batteries aren't connected. So there's no way for the A plus to come over here and operate our filament string. What does happen is our B plus goes up, as before. I mentioned this just a minute ago. Goes up, goes through half of the primary. I'm going to try to keep on the lines here as best I can. And we'll change colors. When it comes out of our cathode, here's where things really get cute. We have our cathode bias resistor here, but we also have another path through this R15 that comes down here and goes through the heater string. Now this is the first time I've encountered this setup. So what they're using, see this, the 3Q4 filament is completely out of the circuit because this over here is open. So there's nothing, there's no current going to the 3Q4. The 3Q4 is now totally out of circuit, not doing anything. And we're operating on the other half of the 117N7. It's cathode bias supplying the heater current or heater voltage for our RF amplifier, our IF amplifier, our our converter, our RF amplifier, our converter, our IF amplifier, our detector first audio, and then our audio comes down, and instead of going to the 3Q5 goes down here, and we have audio out of the unit. Now this radio is on the way, but this is kind of a preview of what we're going to be seeing when the set arrives. And I was just intrigued by this. I just had to have one of these sets in my possession, and hopefully, whoop, why is it not clearing out now? I guess it only allows me to back up so many steps. I don't have any capture software for my editing. I can't capture live screen data, so I'm doing this with Paint. Anyway, I thought that was very intriguing. I have never seen a set that used the cathode bias, whoops, wrong line, this way, used the cathode bias of a tube to supply the heater string of the 1R5 and the 1T4 and the 1S5. That's just, I've never seen that before. Which means we already know what our cathode bias is set at, 4 volts for 1 volt tubes. And just as an aside, if you ever get one of these sets and turn it on and you look inside and say, oh, the tubes aren't lit, well, you won't be able to see them anyway. These are true filaments in these tubes. They're designed to run on a 1.5 volt battery. In a lot of cases they run them on just a D cell, and they don't light up red like you're used to. They just get warm enough to cause emission on the cathode. They have a coating on the filament that creates the electron stream, but unless you're in a totally blacked out room and your eyes have adjusted to the dark for 2 or 3 hours, you won't even be able to see these filaments glowing. They are just barely, and I mean barely, a dull red in most cases. So don't think they're burned out because you can't see them lit in a lit room. The only way to check them out is either with a tube tester or with an ohm meter that only impresses 1.5 volts across the heaters. Make sure your tester is 1 D cell or 1 C cell. These sets that have 2 or 3 D cells or 2 C cells for the low ohms range will burn the tubes out. You can only hit these filaments, or the filaments, with 1.5 volts. And something else I should have mentioned about this set. Let's get back here. I've got to redo my brushes. I started to put everything away to edit this, and I finally remembered that I forgot to point out something else on this thing. And I also have a shield up in front of the microphone now. See if it makes any difference in the audio. Or heck of my brushes. Yeah, we'll go with blue. How's that? Big size brush. The last couple of All-American 5/6s that we worked on had RF amplifiers in the front of them, as does this set right here. And you know, they were untuned, but just like our car radio, it appears we have part of the tuning capacitor here, of course, on our antenna, as is normal. We have tuning here on our oscillator, as is normal. But just like the car radio we're fixing up for Tom, we have tuning on the RF amplifier stage as well. So I have hopes that this set may be a fairly decent performer. You can see we have a trimmer right here on that section of the tuning. It looks like a 3-gang cap from what I can see. We have a trimmer here, as well as, oops, I went off the screen with the mouse and now I'm lost. I got 4 monitors here and something. Oh, it's such a tiny little thing on this screen. And here. So we have a tuned RF amplifier in the front end, as you know, well as the car radio did. So I'm hoping that this is a decent little performer when it comes in. We shall see, but it was just interesting to see in a small radio like this. Now normally they would have something along these lines. They would have a line connecting these two, and they would have a line connecting this, showing you that they're ganged. But this is a fairly early schematic. But it's just interesting to see a trimmer and tuning capacitor in this section, trimmer and tuning capacitor in this section, as well as our oscillator. So we got 3 tuning points just like the car radio. Let's keep our fingers crossed, shall we? Okay, that's it. If anybody found this interesting, I can continue this series. As I flip through these books, I'm finding tons of intriguing schematics and different things that I've not encountered before. So if you like this, give it a thumbs up. Make some comments saying you'd like to see some more of this type of video, and I'll continue to do so, and if not, I'll just drop them. But the nerd in me just fell in love with this set when I saw this right here. Okay, that's it. Short and sweet. I'm the Radio Mechanic. Hope somebody found that kind of fun, and we'll see you after the holidays. Merry Christmas, everyone.